Hello, I'm John Harrison, and this short video is on the production and handling of bilirubin. Here are the objectives. At the end of this video, you'll be able to discuss the origin, transport, and fate of bilirubin in the blood, describe the handling of bilirubin by the liver, including uptake, conjugation, and secretion into bile. Distinguish between prehepatic, hepatic, and posthepatic causes of jaundice and their manifestations. Bilirubin is a breakdown product of heme, so let's begin with the destruction of red blood cells at the end of their approximate 120-day lifespan, a process that usually occurs in the spleen. Red blood cells that reach the splenic cords have to work their way through a specialized endothelium to reach the splenic sinusoids and get back into the venous circulation. Red blood cells that are senescent, damaged, or misshapen and have lost their characteristic biconcave disc shape will be unable to navigate the space between the endothelial cells, and then they'll be phagocytosed by splenic macrophages, and they'll be their hemoglobin and associated heme groups will be degraded. And here you can see some splenic macrophages and red cells that they have phagocytized. Within macrophages, heme is degraded by a two-step process to form bilirubin. First, heme is converted to biliverdin via an enzyme called heme oxygenase that liberates the iron that can then be stored in the macrophage as ferritin for release at some future time when the iron is needed. Biliverdin is then reduced to bilirubin, and bilirubin is released into the bloodstream where it's not soluble in the aqueous medium, so it has to be bound and transported to albumin, much in the same way that fatty acids bind to albumin for transport. This form of bilirubin is called unconjugated or indirect bilirubin. It's called indirect because it requires a solubilization step in order to be assayed. Upon reaching the liver, albumin that's transporting bilirubin can get through the specialized fenestrated endothelial cells of the liver into the space of DISA. Once there, it can access the basolateral membrane of the hepatocyte. Bilirubin is then transported across the basolateral membrane via an organic acid transport protein. Once in the hepatocyte, bilirubin is then conjugated to glucuronic acid by an enzyme called UDP glucuronol transferase, which can add either one or two glucuronic acid moieties to each bilirubin. This conjugated or direct bilirubin now has aqueous solubility and can be secreted into the bile canaliculus in order to be excreted. The transport protein is called a multidrug resistance protein 2. This small region of membrane between the hepatocytes forms a canaliculus, and this is the apical membrane right here of the hepatocyte. Bile salts, phospholipids, and cholesterol are also secreted across this apical membrane into the canaliculus and play an important role in the emulsification and absorption of lipids from the diet. In this slide, we've zoomed out to show the biliary system. From the canaliculi, the bile travels into larger structures called bile ductules and ultimately into the so-called hepatic ducts. Bile can then be stored in the gallbladder until a meal is consumed, at which time the gallbladder contracts, the sphincter of Oddi opens, and bile can be secreted into the duodenum. Conjugated bilirubin is not reabsorbed by the small intestine. However, once it reaches the colon, bilirubin is deconjugated by bacterial enzymes and converted to a compound known as urobilinogen. Some of that urobilinogen can then be reabsorbed and redelivered to the liver, where it may be secreted once again into the bile. Some of it, however, may reach the systemic circulation and can be secreted or excreted by the kidney. The remainder of the urobilinogen in the colon is converted to urobilins and stercobilins, which are excreted in the stool. Stercobilins in particular give stool its brown color. So if for some reason, for example a blockage in the biliary system, bilirubin is not reaching the intestine, the stool may have a very pale color. Normally, the rate of production of bilirubin is matched by the rate at which bilirubin is excreted. However, sometimes, either due to excessive production of bilirubin or an inability to excrete bilirubin, jaundice can occur. Jaundice is a characteristic yellow discoloration of tissue resulting from bilirubin deposition due to high levels of bilirubin in the blood, or hyperbilirubinemia. This can be best detected in the sclera, or the whites of the eyes, and in this case it's known as icterus. There can be several etiologies of jaundice, and the problems can occur at multiple levels. They can either be prehepatic, or problems with the liver itself, hepatic, or there can be posthepatic etiologies as well. Prehepatic jaundice is due to excessive destruction of red blood cells. That will be associated with an increase in the production of bilirubin, and the bilirubin is produced so quickly that it can't be processed fast enough by the liver. So that will lead to an increase in the circulation of indirect or unconjugated bilirubin. So this will be increase in indirect or unconjugated bilirubin. Diseases affecting the liver, such as hepatitis or cancer, can affect multiple processes, including the uptake of bilirubin from the circulation or the conjugation of bilirubin within the hepatocytes, or a failure to excrete bilirubin into the bile. Therefore, liver disease can often be associated with increases in circulating indirect as well as direct bilirubin. Posthepatic jaundice results from pathologies that occur within the biliary system or the pancreas. Cholestasis refers to an impaired flow of bile, and it can result either from a gallstone, often in the common bile duct, or can be due to a blockage caused by pancreatic cancer. It's worth remembering that there's an important anatomical relationship between the pancreatic duct and the common bile duct, since they both empty into a structure called the ampulla of Vater just before the sphincter of Oddi and the entrance to the duodenum. This anatomical relationship means that problems in the biliary tree can often affect the pancreas and vice versa. Cholestasis results in the backup of conjugated or direct bilirubin into the blood, since conjugated bilirubin in the hepatocytes is not able to be excreted into the blocked canaliculi. It refluxes into the circulation where it can be detected as direct bilirubin. And I thank you for your attention.